Hello, I am Dr. Cassandra Marion, Science Advisor at the Canada Aviation and Space Museum, and today I am pleased to speak with a literal Martian rock star, Dr. Chris Hurd, Professor in the Department of Earth and Atmospheric Sciences at the University of Alberta. Dr. Hurd is a planetary geologist and global expert in Martian meteorites, and he will play a key role in the Mars 2020 Perseverance Rover mission, which launched in July 2020 and is scheduled to land very soon, February 18th, 2021. So welcome. Thank you so much for talking to me today, Dr. Hurd.
Nice to see you.
So tell us about the Perseverance Rover mission. What is the purpose of this Mars 2020 mission?
The overall purpose of the mission is to look for signs of ancient life on Mars. And if that isn't enough, it will also collect and prepare a cache of samples that will be left on the surface for possible return to Earth by future missions.
Excellent. So why is it important that we are sending yet another mission to Mars? Like, how is this mission different from those before, like the Curiosity rover that's on Mars now?
There's some similarities and differences. The actual structure of the rover is very much like Curiosity. It was built kind of on the same sort of bus. But the key differences are that it has an updated suite of instruments on board to allow us to explore the rocks at the surface, to look at the weather, even to test things like making oxygen out of the Martian atmosphere for human exploration in the future. And the sampling system that will actually core rock samples and cache them, leave them on the surface. Why do we need another rover now of this capability? It builds on all of the previous exploration of Mars that we've done, both from previous rovers and landers and orbiting spacecraft that have been looking at the surface at different in different wavelengths and different resolutions. We know a lot about Mars now, about its history, but there are some really key things that we need to test. And this rover will test some of those, including the primary one, which is, did life ever exist on Mars?
Fantastic. So what is your role on the mission?
I am what's called a returned sample scientist. And that is somebody who has expertise in what you do with samples when they're in the lab on the Earth. My expertise comes from working on meteorites from Mars, which are rocks that are delivered naturally to the Earth from impacts on the surface of Mars, that I did my PhD on and have been working on ever since, as well as work that I've done here at the University of Alberta on the university's meteorite collection, as well as building a facility that curates samples under extremely pristine conditions. So, which is also kind of part of what you need to know for bringing samples back from somewhere else. So those are some of the reasons why I'm on the mission. And but my role is really to help the mission decide where and when to sample, and to make sure that all the documentation is there, all the information that we need to know about that particular sample is there, because that's the key thing that is so important for these samples, is that every single one of them are going to know exactly where they come from on the Martian surface.
And how do we collect those samples? How does Perseverance collect the samples?
It has a system, extremely complicated engineering system, that allows it to, on the end of the arm, it will reach out, and in addition to the instruments on the arm that can look at the texture of the rock up close, that sort of thing, as well as the other instruments on board that can look from a distance, tell us what the rocks are about, give the context, you can actually put that arm up to the rock, and it has a coring device that will actually core into the rock. It will produce a rock core sealed inside of a sleeve that's about, I kind of think of it as like the size of a highlighter marker, so a little bit fatter than a typical pencil or pen, and a little bit shorter. And we hope, if it goes well, each one of those will be about 15 grams of rock sample. That is, then each one is sealed inside its own tube and then carried along on the rover for a while. And then at certain points, we'll make a cache of samples. So put them all together in one spot sitting at the surface.
Okay, and how long will it be before these samples are returned to Earth?
The current plans have that what's called a fetch rover will actually land on Mars in 2026 or 2027 thereabouts, and it will drive to a cache of samples and collect them, and put them into a package, basically, put them on a rocket on a lander that's also come down with the rover, and blast off of the surface of Mars into orbit around Mars, where that package will then meet up with an orbiting spacecraft that will grab it and bring it back to the Earth. And the earliest that will happen is 2031 is when they'll actually make it back to the Earth. And as you can tell from what I described, there's a number of steps involved, including, the fetch rover collecting up the samples. And we also have the potential that we would, on the rover mission, at the end of the rover mission or towards the end of the rover mission, we would actually have a number of samples on board that we could actually even hand off to the fetch rover. So that sort of remains to be seen.
And so once we have these samples on Earth, what's needed to safely store and care for Mars samples?
That's a good question too, because these are unlike any other samples that we have ever been brought back from another planetary body, including the moon, including asteroids, including samples that are coming back now from asteroids. These are different because they could have evidence for ancient life in them. So, and there's a very, very slim chance that they could have existing life in them. It's what's called planetary protection. We want to make sure that Earth is protected from any microbes or something that are on Mars, and vice versa. So it's a whole other type of sample, and there's a committee that is looking at that and defining exactly what a sample receiving facility will need to encompass, because it needs to be built from the ground up, for the reasons that I mentioned. You have to be able to protect the samples from contamination from the Earth getting in and muddying up the signature that we might get from the samples, especially if we're looking for evidence of ancient life. And we also, of course, need to keep whatever's in the samples that could be dangerous away from the Earth environment.
So tell us more about the landing site at Jezero Crater. Why was it chosen?
Oh, Jezero Crater is a fascinating area. It's an impact crater, an ancient impact crater that's about 45 kilometers across. And it has in it rocks that were deposited when a river was flowing from outside the crater into the crater. And it implies that the crater was actually filled up maybe to a depth of a couple hundred meters, because the river flowed into this crater lake and then deposited these sediments in what's called a delta. And the idea is that we will land somewhere around the edge of that delta, probably on the crater floor, but maybe up on the delta. And the crater itself has been filled in by different types of rocks, and the topmost one may even be some kind of volcanic deposit we could land on. And so we're going to explore that. We're going to explore the delta. And then as we go toward the edge of the crater, there's other rocks that may have been deposited on the shoreline of this ancient lake that could have evidence of ancient life in them. And so all that's to say is that, what I just described is, on the whole, a habitable environment. If we had an environment like that anywhere on the Earth, we'd expect to find life in it. So that's the reason why we're going to this particular location. What I just described is all part of what's called the prime mission, the 1 Mars year, 2 Earth years, landing near the delta, driving up onto the delta, over to the edge, and then onto the crater rim. But if the rover health is good, we'll do what's called an extended mission, which is an additional 1 to 2 Mars years, where we would explore outside of Jezero Crater, which is even more diverse in terms of the rock types that we get there. And the rocks are even older than the rocks that are in Jezero Crater itself. And so the idea is that by the end of it, hopefully we will have explored quite a large area of territory on Mars and collected samples from all of that, and have 30-some really, really compelling, diverse samples from a whole range of Mars's history. One thing about Mars is that we know it went through some kind of a strange transition right around the time when these rocks were deposited in Jezero crater, going from water that was neutral pH to more acidic, and then Mars drying out into this really cold, rusty desert, which it is today. And the rocks from this period in Jezero crater are around that age. And so that's one of the sort of big picture questions over and above, whether life was there. So why Mars went through this transition from being largely habitable to not so habitable today. So this crater lake could have been there 3.84 billion years ago, and the rocks are there for us to explore.
Can you give an example of what you are looking for, maybe what geological or biological evidence that you might find?
The exciting thing is that there are so many different rock types in Jezero crater and outside Jezero crater that it's almost like there's something in it for everybody. My research is on these meteorites from Mars, which are all igneous. There's a bias actually in how they're sampled from Mars, which is another reason why we need to send a rover to go and pick the samples ourselves. They're igneous rocks, they're mostly younger, and they're fascinating. They tell us all this great information about Mars as a planet. I'd like to find something similar, maybe older rocks that are igneous, just because that's my area of interest and expertise, and we can do that sort of comparison with rocks that we already have as the meteorites. But of course, the other thing is, what are those other rock types that we've never seen before in any samples from Mars that we could really explore, especially once they're back in labs on the Earth? And imagine all the different things that we can tell about Mars as a system, as a planet.
And do you think that we're going to find signs of life on Mars?
That's hard to say. I'm not a betting person, so I'm not going to say sort of one way or the other. I don't think. I think what is fascinating either way is that it is likely that we will find habitable environments. That is, rocks that were laid down under conditions that, if they were on the Earth, we'd expect to find life. Examples include the delta, especially the bottom of the delta, what are called the really fine grained, like sort of really silty or clay-rich sediments. Those on the Earth in a delta are full of organic matter. So that's why that's a target. Or some of these deposits that are on the margin of the crater lake that have the mineral carbonate in them. We know that from orbit, from signatures of the mineral from orbit. And those could end up, hosting what are called stromatolites, which are structures that are built by bacteria that we know of on the Earth. If we go to those spots and we find that, based on the rocks, that these were habitable environments, in other words, lots of water around and the conditions were suitable, and we see organic matter or hints of it, that's going to make us really excited. And we're going to collect samples for sure, and then we need to bring them back to the Earth to really tell one way or the other whether life was there. But if we don't end up finding any evidence of life, that also is a key finding, because it tells us that there were environments on Mars that were habitable, but were not necessarily inhabited. And it tells us that that would be a fundamental discovery to tell us that, life did not develop on Mars, or at least in a particular window of time, for example.
And what are you most excited about?
Well, I've been wanting to work on samples from Mars since I was about 13 years old. It's the reason I went off and did a PhD on meteorites from Mars. And it's what has kind of driven a lot of my research in my career. And so for me personally, it's extremely exciting to be chosen and to be involved in this mission, to have the support of the Canadian Space Agency to actually be involved in the mission, to help to make that dream come true, because I'll be there with my colleagues on the mission, deciding where samples get collected. And then hopefully, if all goes well after that, be there when the samples come back, and then be able to do research on specific samples. And I expect I'll have one or two of my favorites from the mission that I'll really want to be able to study in person, as it were. So for me, it's a long-term view, but that's the really exciting thing. That and just exploring, because I've never been involved in a mission like this before, and this is a phenomenal opportunity to be involved day to day throughout several years of exploring Mars and seeing new things with everybody else on the mission.
So I fear asking this question, but because I don't want to jinx anything. But what happens if the landing doesn't go as planned? Is there a contingency plan?
There are always contingency plans. That's one thing I've learned in working with NASA and engineers at JPL, is that there are plans for everything. And so they've envisioned different ways in which things can go wrong. They practice it, they plan for it. And so there's always a plan in place. We can't really say what's going to happen, but there's always a plan in place for if something goes a little sideways.
Well, I am so excited for more Mars exploration and all of the science that will come from this. So thank you so much, Dr. Hurd, for sharing your knowledge about the Mars 2020 Perseverance rover mission. Really appreciate your contribution, and I wish you and the mission team a successful soft landing, future exploration of the red planet, and of course, safe return samples to Earth and to Canada.
Thank you very much. My pleasure.
So a note to our viewers, please follow Canada Aviation and Space Museum on Twitter and Facebook, as we will be posting more on the Perseverance rover mission in the coming weeks. To Mars and beyond!